Inequalities. Form 3 inequalities to satisfy the unshaded region R. So the first thing we're going to do is to identify the lines that border the required region, that is region R. Those are the lines, line 1, line 2, and line 3. Once you have identified the lines, get the equations of each of those lines. So we're going to begin with line 1. Line 1 is the y-axis, as you can see, that is the y-axis. What is the equation of the y-axis? Is x is equals to 0. Now let's proceed and get now the inequality. The inequality will be given by this sign substituted with either less than or equal to, greater than or equal to. So that is what you're supposed to substitute where we have equal sign. How do you know the sign that you're going to insert there? When you look at that line, the y-axis, look at the side that is shaded. The side that is shaded is the unwanted side. So the unwanted side is the one to the left of the y-axis, and that is the side that is less than. The values to the left of the y-axis are less than the values to the right of the y-axis. So all the values to the right of the y-axis are greater than, and that is why we have the region R. Therefore, the sign that you're going to insert here is x is greater than or equal to 0. Y greater than or equal to, y equal to and not greater than, since that line is continuous and all the points that lie on that line are also going to satisfy the inequality. We go to line 2. Now for line 2, we can't just get the equation of that line directly. We just need to get 2 points on that line, and the 2 points were the ones that you can identify easily on that line is this point. We have a point here, we label it, we have that point, and we also have this point here. So 2 points on that line. That is how we get the equation of any line. First get the 2 points. So first one is 0, 8, 0, 8, and the other point on that line is 8, 0. Once you get the 2 points, just normal way we get the equation of a line, get the gradient. Gradient is change in y, so take 0 subtract 8 over change in x. 8 subtract 0, and this one will give the gradient as -1. So the equation is given by this, the standard equation of a straight line. Y is equals to mx plus c, where m is the gradient. So y is equals to m is -1 plus c. So now the only thing that is remaining is getting the value of c. C is the y-intercept of that line. The y-intercept means the point at which that line cuts the y-axis. That is the y-intercept, and it is cutting the y-axis at 8. So c will therefore be 8. So the equation will be given by y is equals to -x plus 8. C is 8. So now, for getting the equation of the line, you can leave that equation like that, or you can write it like this. Y, you can bring -x to the left hand side, you get y plus x is equals to 8. Now it is time to determine the inequality that you're going to insert there. Now to do this, you just need to pick a point on the required region. Any point that you're going to pick on the required region. I'll choose 2, 2. 2, 2 will lie somewhere here. 2, 2 will lie somewhere here. So a point in the required region. So 2, 2. Then you know, x is 2, y is 2. Substitute these values of x and y in the equation of the straight line. So y is 2, x is 2. So this will be -2, -2 plus 8. So this will be 2 is equals to 6. So after getting that, remember we want to determine the inequality sign that you're going to insert there. So when you look at the point that you've pick the point on the required region. So the inequality sign that you're going to insert there should be true. So what can you say about 2 and 6? Of course, we can say that 2 is greater than or equal to 6. Why equal? Because that line again is continuous. If it was broken, maybe we could have written it as just greater than. By putting equal sign, we mean that even all the points that lie on that line will also satisfy the inequality. So 2 is greater than or equal to 6, since we have picked that point in the required region and it must be true. The sign that we insert there must be true. So now coming back to our inequality, this is how we're supposed to write it now. Y, then we put this greater than, the sign that you just identify. Y is greater than or to negative x plus 8. Alternatively, you can also use this format of the equation. Y plus x is equals to 0, and we just follow the same procedure. We pick the point on the required region. 2 to x is 2, y is 2, then substitute it here. X is 2, so it will be 2 plus 2 is equals to 0. So this will be 4 is equals to 0. So identifying the sign that you're going to insert there, because that point is lying in the required region, the sign that we put there should be true. So what can you say about 4 and 0? Because 4 is greater than or equal to 0, and therefore the inequality is y plus x is greater than or equal to 0. So this is just another way. So you can write it like that, or maybe you can put it like y is greater than or equal to negative x plus 8. So these two are okay when you leave them like that. So that is how we write the inequalities satisfying that region. So the first one, there's one that is missing. We are not yet done. We also have the last line, line 3. Line 3 is the next. So line 3 is here. Line 3 is the x-axis. This is the x-axis. What is the equation of the x-axis? It is y is equals to 0. Again, we need to identify the inequality sign that you're supposed to insert there. Now to do that, just look at that line, x-axis. The side that is shaded is the side that is below the x-axis, and that is the side that is less than. The values that are below that line are negative. So the side that is on top of that line are greater than, the values are greater than, and that is where we have the required region. So therefore, the sign that you're going to insert here should therefore be y is greater than or equal to 0, not less than, since less than is the other side that is the bottom of that line, x-axis. So I think now we have written all the inequalities, the 3 inequalities. So for line 1, we identified for line 1 is there. So for line 1 is there. Then for line 2, we have these, either of these. Then for line 3, we have it there.